In this video, we're going to learn about decoders. So a decoder is a combinational logic circuit that has n inputs and 2 to the n outputs. And how does this one work? So in this case, the output that is going to be turned on or that is going to be a 1 depends on the value of the inputs. So for example, if W1 and W0, which are the inputs, are 0, 0, then my output 0 is going to be on and the rest of the outputs are going to be 0. In the case of this one, for example, that I have a 1, 0, my output 2 is going to be on and the rest are going to be zeros. How do we design for this? So you can think of this as 4 separate truth tables. Okay, so why 4 separate? Because we have 4 outputs and we can have 0, 0 with the y0. That's going to be a truth table and we just designed for that. So you can see that it's going to be a min term for each of these outputs. So for example, for this output, we're going to have a W1, W0, not, right? For this output, we're going to have a W1 not, W0, and so on, right? What about this one? This one is just a min term, W1, W0 not, and this guy is just W1, W0. So how do we draw that schematic? We're going to have W1, W0, not, not. And then we're going to have a, so that's y0, y1, y2, y3. And this is going to be W1 not, W0 not, W1, W0, so that's a 1, 0, 0, 1, that's a 1, 0, this is a not, and this is a 1, and then this is a, this one, and maybe this is in the way. And that's it. So we have these 4 outputs. To have a 0, 0, 0, 1, 1, 0, and 1, 1. So basically each of the min terms correspond to one of the outputs. So now we can also include an enable. So that means that when our decoder is enabled, it functions as a regular decoder. And when our enable is 0, then we don't care about the inputs. All of our outputs are going to be turned off, or they're going to be equal to 0, which means this enable is kind of like an on and off signal for the decoder. So how would that look like in a diagram? So we're basically going to end the enable. So we're going to end the enable. So we're going to have another one. It's going to be our enable signal. So if it's enable is equal to 0, you can see that anything ended with 0 just going to be a 0. So we can have decoders that are 2 to 4, 3 to 8, 4 to 16. So n inputs, 2 to the n outputs. And the general diagram or block diagram looks like this. How do we implement functions? So we're going to do an example. Use a 3 to 8 decoder and an OR gate to implement the function below. Okay, so we're going to have a 1, 2, 3, 3 inputs. We're going to put the A, B, C, and then So if it's going to be 0, 0, 0 all the way to 1, 1, 1. Okay, so that's a 0, that's a 1, that's a 2, 3, 4, 5, 6, and 7, right? From 0 to 7. So what's going to happen is that we're going to select this one, 4, 5, and 7. I'm going to put an OR gate. And so that's it. So if any of these midterms happen, then our f is going to be equal to 1. Now a multiplexer is just basically a decoder. Remember the multiplexer goes from 2 to 1, 4 to 1, 8 to 1. That the multiplexer is the opposite of the multiplexer. In this case, we're going to go from 1 to 2, 1 to 4, and etc. But it's basically a decoder with the data input connected to the enable, and the select inputs will be these W0 and W1. Okay, so now we're going to use a 2 to 4, but now remember the multiplexer A and B, for example, and depending on A and B, so 0, 1, 2, 3. So if we had a 1 here, for example, then it would pass, and a 0, 0, it would pass this signal here, right? So I'm going from 4 possible to 1. And in this case, I want to say, well, I have an input value. For example, let's say I have an input value of a 0, and I want to pass it to one of these 4. Okay, so that would say, okay, if I have my A and B here, then I can say, well, just pass it to the 0, 0, and that value will be sent to here, right? And if I have a 0 as my data, I have a 0, it would still pass it to here, but now I have a 0. So it's kind of like taking the serial input. I either turn it on and off, and it's gonna pass it to this signal or to this other one or to this other one. So that's what basically is the multiplexer.